The quality of education and social integration in special needs schools are greatly impacted by communication barriers that exist between students with speech or hearing impairments and their classmates, teachers, and the greater school community. Even though sign language is a useful tool for these children to communicate themselves, but achieving inclusive education is hampered by teachers and non-special needs students' limited knowledge and proficiency in the language. Assalamualaikum warahmatullahi wabarakatuh. My name is Darwish Asraf Fatwi.
I am Ukasha Zuhair bin Rozaimi.
And I'm Nurmadiha binti Nur Muazzam.
And here, we are representing a sign language detector with audio speech.
Sign Language Detector, also known as SLD, is a technology to help children with speech and hearing impairment communicate in special education settings. The technology uses machine learning and computer vision to recognize and decipher sign language motion and convert them into real-time speech. Existing sign language interpretation methods, including static device or human interpreters, are either resource-intensive, scarce, or not made for dynamic, real-time classroom environments. These restrictions impede special needs people's capacity to communicate their ideas, fully engage in class activities, and comprehend spoken language through interactive methods. An accessible, real-time system that can decipher sign language motion and translate them into audible speech is therefore desperately needed. For pupils with special needs, such a system would promote any inclusive learning environment, assist personalized learning, and close the communication gap.
The development of sign language detector using the audio speech is the primary objective of the research. Additionally, the project targets participants in age of 7 years old to 60 years old in age and above, who are able to acquire and understand 10 basic English words in sign language. Our first goal is to use a vision-based system to create a real-time sign language detector with a 10 typical basic English terms. Second is to improve image stability and reduce environmental concerns during the image acquisition process.
Methodology, real-time audio speech translation from sign language gesture is part of system design. It is made up of 3 main parts. First is gesture detection. In gesture and movement are recorded by a camera where a dataset compiles a list of 10 commonly used fundamental phrases in English Sign Language. Second is that gesture are categorized into pre-established groups by machine learning models where hand tracking tracks hands and extract important landmark using pre-trained models like MediaPipe. Third, machine learning models using hand landmark coordinates train a supervised learning model to categorize motion into specified group. Here are the examples of how SLUs were functioning. Besides, it also has other words which are hello, goodbye, yes, no, sorry, please, hop, you're welcome, and I love you.
A flowchart for the SLD with audio speech system is shown in the figure. The 3 primary phases of the flowchart are input, process, and output. Based on the diagram, the following is a description of each step. First, data collection will involve utilizing devices like a camera to collect a dataset of hand motion. The gestures are captured in a variety of settings, including lighting and angles. Next, extraction of features from the gathered data like hand landmarks are recognized and normalized using MediaPipe. For the process, training and development of process models will categorize gestures, and model deployment for classroom and other learning settings can employ the trained model in real time. And the result, real-time hand gesture recognition, is achieved by the system using the deployed model, and TTS engine is used to translate recognized gestures gestures into speech and text. For accessibility, both visual and auditory input are offered.
The 93% accuracy rate of the sign language detector or SLD with audio speech indicates that more development is required. By modifying the hyperparameter of the model used to train the data or the strategy used to partition the data, the detection accuracy can be increased.